What up, what up? I'm the math teacher Goat, and today in AP Precalculus, we are doing a full lesson in 3.1 periodic phenomena. This is the beginning of Unit 3, the last and final unit before that AP exam. Introduces trigonometry, so that's fun stuff. Speaking of fun stuff, make sure you go to the description and download the notes so you can follow along, print them out. Also, like and subscribe, it goes a long way for me. Now, our warm-up, kind of strange. Divide and find the remainder. Yes, this is real. All right, so regular old long division. 25 goes into 52 twice. Multiply it by 50. Subtract. Bring down the 2. Bring down the 9. Do it again. 25 goes into 29 one time. 1 times 25 is 25. Minus, you get 4. Drop down the 7. 25 goes into 47 one time. 1 times 25 is 25. Subtract, and you get the old Taylor Swift special, which is 22. The remainder is 22. Now, why in the blazes did we do that? Well, you'll see in a minute. It has to do with periodic functions, though. Everyone likes a good old-fashioned church hymn. This hymn has 5 verses and is broken down into 3 lines per verse. Each line takes 12 seconds to sing, according to what I just made up. What verse and what line should you be singing after 135 seconds? What do we have? We have, oh, my favorite, Oh, Sing a New Song to the Lord. Let's sing it together. Oh, sing a new song to the Lord. That took 11 seconds. Sing all the earth to God. To God sing. Everyone, bless his name. Show. Does that show? My eyes are so bad. Show still his saving health abroad. And then there's more, of course. But that's all I'm going to sing for today. I don't want to get any copyright issues because that'll probably happen. But anyway, as you can tell, it took 12 seconds to sing each line. I care about where I am after 135 seconds. Well, this is what I'm going to do. I'm going to divide 12 into 135 and do what I did up there. 12 goes into 1 0 times. 12 goes into 13 one time. 1 times 12 is 12. Subtract 1, drop down to 5. Okay, so 12 goes into 15 one time. 1 times 12 is 12. Subtract 3. Or subtract 12, get 3, remainder 3. Now, what this means is after 135 seconds of me singing this song, I have read 11 lines, and I'm 3/11ths, I guess. Terrible band, but, you know, coincidental. I am 3/12ths, rather. So 1/4 of my way into singing that whatever line. So line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm on that verse right there, and I'm probably about to go, name. That's where I'm at. Okay? So periodic functions have to do with remainders. Okay, and the remainder and the division part helps me figure out about where I am. I am 11 and roughly 1/12 or 1/4 into me singing this song, 11 lines in. All right, so a periodic function is a mathematical function that repeats its values in regular intervals or periods. Okay, periodic function. So we've seen this before in Unit 1. We've got these wavy looking things, right, that kind of repeat over and over and over again. Whenever we would have a Ferris wheel problem or a car is going around in a circle problem, we had these wavy looking things. Now the period is the x distance it takes to repeat. the x distance it takes to repeat. So it doesn't matter where you decide to repeat it. Sometimes it's easier to go at the tippy tops of these periodic functions, and that you can measure your period out that way. It doesn't really matter. You can go, in the middle here and do the same thing. You can go at the bottom here and do the same thing. You can go at a random spot right here and do the same thing. You'll get the same period every single time. The amplitude is half the total height. Half the total height. Not the total height, half the total height. Okay, that is the amplitude. That is the period. Let's answer some questions. Now, this is where I'm going to be awful. But sketch the rest of the graph on the given axes. So what I like to do when I'm being asked to sketch this stuff is look for like landmarks of my picture. Okay, if I were to start here at 0, 0, which I am, like 2 units in, I hit my peak. All right, 4 units, I repeat. 6 units in, I hit the bottom. And 8 units in, I do a complete repeat. So my period here would be 8. Okay, my period is 8. And it repeats, so that's because it repeats every 8. So I'm going to go up 3 and then back down somewhere over here. Going in reverse, I'm going to go down 3 at -2. At -4, I'm hitting my x-axis again. And here, up there, not there, I'm at my peak. So, drawing these things are not my forte. I'll do the best that I can. Pretty bad. And then up here, and then right around there. Okay? This has a period of 4. It goes down 2, up 2, down 1, up 1. Down 2, up 2, down 1, up 1. Down, Going backwards then, it'll be down 1, up 1, down 2, up 2, down 1. So I'll draw that out to the best of my ability. Like that. Period appeared to be 4. Total amplitude for this was 3 because it's, half the total height. So bottom out at -3, peaks out at 3. That's a height of 6. Half of that is 3. And this has an amplitude of 1, period of 4. To find the period of the function, find a place where the function repeats. And I guess we're going to calculate distance. The x distance, of course. Okay. So identify the length of the period for each function. So, bottoms out at 1, peaks out at 3. Bottom, peak, bottom. So pick 2 peaks, I guess. And that distance goes from 1/4 to 3/4. So 3/4 minus 1/4 is 2/4, which is a half. All right, this is spread out a little bit more. So we really don't see 2 peaks, but I do see 2 bottoms. So that happens at -4 and 12. So the distance from -4 to 12, I could do 12 minus -4, which is 16. To find the amplitude of the function, you take half of the maximum minus the minimum, half the total height. And that's probably how I should have read that. I probably should have gone like, I don't know, if we're talking about on an interval x1, x2, you would just do x2 minus x1. All right. Same thing here. To find the amplitude of the function, take the half of the maximum minus the minimum. Oh, okay. What is the amplitude of each graph above? All right, well, the maximum is 3. The minimum is 1, so half of 3 minus 1 is half of 2, which is 1. This guy, my maximum is 3. My minimum is -1, so half of 3 minus -1 is half of 3 plus 1, which is 4, and half of 4 is 2. Okay? Not too complicated yet. Let's do the same thing. We've got amplitude and period of this guy right here. So the amplitude, the very tippy top is at, what is that, 5. And then the very bottom is at 1. So half of 5 minus 1 is half of 4, which is 2, just like you were. And then the period is I just pick a good spot where they repeat, like here at 1 and 5, they seem to repeat. So 5 minus 1 is 4. Okay? Again, nothing crazy, nothing crazy, nothing crazy, not yet. Below is one cycle, also known as the period of a periodic function. So here it is. Find y. Ooh, so this is where we're kind of getting from our warm-up. Find y if x is 21. So what we need to do is common sense would say, all right, what would happen at 5? I know 5 would behave just like 1, right? Because this has a period of 4. 5 would behave just like 1. So what would happen at 21? Well, it would behave just like if you were to divide 4, my period, into 21, 9 plus 10, the remainder would tell you how it behaves. So I'm going to do 4 divided by 21, which is 5. Multiply 5 and 4, you get 20. Remainder is 1. So your remainder is exactly the placement where it would be if it was on the original problem. So since my remainder is 1, at 1, we're at 0. So y would equal 0 at 21. Is y increasing or decreasing on the interval 11, 12? Well, let's find out how the interval 11, 12 acts. Divide 4 into 11, and then we'll divide 4 into 12. Okay, we got what? We got 8. We got 2 here. 2 times 4 is 8. 11 minus 8 is 3, so the remainder of 3. So 11 acts is 3. Now that would mean that 12 acts like 4. But we get that here because, you get 3, multiply that, get 0, remainder of 0. So you can do remainder of 0 or remainder of 4, however is more aesthetically pleasing to you. And on the interval 3, 4, y is increasing. Okay? Okay, so what do we have here? We have a period of 1, 2, 3, 4, 5, 6, 7, 8. Right? It doesn't really show us what happens from 0 to 2, but you know what? It looks like if it repeats here, it's just going to, kind of curve down like that. So I have a period of 8. Is the function increasing, decreasing, or both on the interval 52? So what I'm going to do is I'm going to divide 8 into 52. Okay, that would be what? 6. 6 times 8 is 48. Subtract 4, or you would get 4 when you subtract that, so that's my remainder. My remainder is 4. So this behaves like 4. Now, I'm not going to do a division problem again. 4 units later is going to behave like 8. 52 to 56 is the same thing as 4 to 8. From 4 to 8, here's 4, 5, 6, 7, 8. What we are doing from 4 to 8 is decreasing. Decreasing and decreasing only. Is the function concave up, concave down, or both on 30 to 34? So 8 goes into 30. That would be 3 times. 3 times 8 is 24. Remainder of 6. So your 6. And then 4 units later is going to be 10. So from 6 to 10 is this guy. 6 to 10 appears to be concave up. Is there a relative maximum, relative minimum, or neither at the point x equals 44? 8 goes into 44 5 times. 5 times 8 is 40. Subtract remainder 4. remainder 4. So what happens at x equals 4? At x equals 4, you have what appears to be a relative maximum. All right. All right. Same thing we got going on here. We have a period of 1, 2, 3, 4. Okay, and so this is going to start decreasing and hitting -2. Okay, just so I can see the first 4 things happening. Period of 4. Is the interval increasing, decreasing, or both on the interval 25 to 27? Well, 4 goes into 25 6 times. 6 times 4 is 24 minus remainder 1. So what happens from 1 to 2 units later is 3. From 1 to 3, it looks like we're just decreasing. Is the function concave up, concave down, or both from 34 to 36? Well, 4 goes into 34 8 times. 8 times 4 is 32. Subtract, and you get a remainder of 2. So from 2 units later to 4, we are going from here to here, and it looks like from 2 to 4, we are a solid concave up. Is there a relative maximum, minimum, or neither at the point x equals 47? All right. 4 goes into 47, 1. 1 times 1 is 4, 0, drop down to 7. 4 goes into 7 one time. 1 times 4 is 4. You get a remainder of 3. So what happens when x equals 3? When x equals 3, you have a relative minimum. Okay. Is this periodic? Why or why not? Based off of what we see here, it looks like as it waves, it seems to get taller and taller and taller. So this is not periodic because it does not repeat. Does not repeat. Not based off of what we see so far. Okay? Because it appears like this is just going to get bigger and bigger and bigger and bigger and bigger and bigger and bigger. Therefore, not periodic at all. A mass attached to a spring oscillates, which means goes up and down, with a period of 4 seconds. The maximum height is 10 centimeters. Okay, so 10 centimeters above the ground, and the minimum is 2 centimeters above the ground. So basically, you have yourself a graph, right? Looks like this. Okay, bottoms out at 2, peaks out at 10, and it repeats every 4 seconds. Okay, that's what we're looking at. Oh, I just did that. Sketch the graph of the spring. If the spring is at its maximum. Great. What a waste. So if it's at its maximum at 0, that means it's going to start up here and then bottom down and then peak and then bottom down. Okay, so it starts out at 0. It hits its maximum again at 4. Okay, and then let's go up here and then hit its maximum at 8. Okay, bottoms out at 2, peaks out at 10. Name an interval where the graph is concave up. All right, well, if this is going to oscillate perfectly, that would be an inflection point, and that would be an inflection point. So I'm going to assume that you're going to be 1, and I'm assuming that you're going to be 3. So an interval of 1, 3 should do the job. I could also do 5, 7. I could do an infinite amount. But that's just one interval where the graph is concave up. A Ferris wheel completes a full turn every 40 seconds. The height of the rider reaches the maximum height of 125 feet and the minimum of 5 feet. The ride begins at the minimum height. Sketch the graph. Okay. So starts at the bottom, then peaks out, then bottoms out, then peaks out, then bottoms out, so on and so forth. It repeats every 40 seconds. The bottom is 5 feet. The top is 125 feet. Name the specific times the rider hits the maximum height within the first 20 or 200 seconds. All right, so if it starts at the bottom, then halfway through its first rotation is where it's going to hit. So it's going to be 20 seconds and then 40 seconds after that. So we'll say time's going to equal 20. Then 40 seconds after that is going to be 60. Then 40 after that is going to be 100. Then 40 after that is 140. Then 40 after that is 180 seconds. And then it won't happen again before 200 seconds. Okay? What is the amplitude? The amplitude is going to be half of the total height. So half of 125 minus 5 is going to be half of 120, which is 60. There's your amplitude. All right. Periodic function g of x is graphed on the right. Find g of 43. So we have a period of 1, 2, 3, 4, 5. Okay. I don't know if I have to do it, but you would basically go back up to here if I wanted to draw it out. And then you would go down to here, and then you would go up to here, and then you would be like a slope of 1, and then like that, and then repetition, repetition, repetition. Find g of 43. Well, this has a period of 5. So 5 is going to go into 43 8 times. Okay, 8 times 5 is 40. Okay, subtract, you get 3, remainder 3. So this behaves the same as where you are at 3, and where you are at 3 is 1, so the answer is 1. Speaking of 1, when does g of x equals 1 on the interval 0 and 20? Well, it's going to hit 1 a bunch of times. It's going to hit 1 every 1 second and every 3 seconds. And then so it's going to be 1 plus 5 after that, 3 plus 5 after that. So the 1 will be 1, 5 after that is 6, 5 after that is 11, 5 after that is 16. Then it's going to hit the 3, 5 after that is 8, 5 after that is 13, 5 after that is 18. So it's going to hit on those exact numbers. Okay? So pretty quick lesson. This is just an introduction to what's going to be called sinusoidal functions. Very important for Unit 3, Topic 3, whatever we're calling this. But yeah, just the beginning of the topic. As usual, thank you for watching. Go to my YouTube and search for AP Precalculus 3.1, and you will hit a bunch of my random AP Precalculus examples. Okay, some of them I found on the internet, most of them I made myself, and it'll just help you further your understanding just a teensy bit more. Thank you for watching. Like and subscribe, and I will see you in the next video. Bye!